My project was about looking at the visible diameter of these quasars, which I did through the images I showed before, just manually measuring it. And I was comparing that to the mass, which I used the spectra for. I used the calculations with the lines, and I did that to find the mass, and then I compared the diameter and the mass, and that was my main project idea. A quasar is like a really, really big supermassive black hole in space, and it's so big that it like pulls all this matter and dust and all this stuff around it, and it starts to orbit it. And because it's going so fast and there's so much gravity, the friction causes like this lots of heat and light and just like a lot of energy, so it becomes a really bright object in the sky. I found that when I compared the mass and the diameter, as the diameter increased, the mass increased, but at a sort of a non-linear rate, like really quickly, which I wasn't expecting actually. So that was a really interesting finding. So I just sort of looked at why that might be, maybe the geometry of the quasar or something like that. But that was my main finding.
So I was testing how different concentrations of fertilizer affect the rate which algae grows. And then from that, I got oysters and I put the oysters in the different concentrations of algae. And I was testing how the oysters were able to remove the algae. I used a spectrophotometer to record the spectral absorbance, and I also used a turbidity measuring device. I found that as the concentration of fertilizer was higher, the algae, the rate that the algae grew increased, but as there was more algae, the oysters were not able to remove the algae.
My project is about comparing the effect of a gyroscope versus the effect of an accelerometer in terms of how much the angle changes once a disturbance is applied. So a gyroscope is a device that measures angular velocity, which is how much something rotates, and then an accelerometer is a device that measures linear acceleration. In order to compare them, I derived a formula that converts gyroscopic data into accelerometer data, so then I could have the same units that compares the devices. I did both a primary investigation and then I found secondary resources to back up my data. So my primary investigation was I coded an Arduino and then I put the Arduino on a breadboard, and then I tilted the breadboard to like specific angles, and then when the breadboard drops, there's like a change in the angle, and then that shows up on the serial monitor of the Arduino app, so then I can see how much the angle has changed. So that was my primary investigation. And then my secondary result was, the first one was a similar concept comparing gyroscope and accelerometers, but it was in the field of sports science. So they had like a gyroscope on someone's ankle, and then they were running on a treadmill, and then they were trying to see how much the angle changes as they were running in the treadmill. My results showed that the gyroscopic change in angle was less than the accelerometer, hence indicating that it is better